In this video, we'll learn about the synthesis environment. Okay, so synthesis environment tools. What are the different tools they use? First is the design analyzer. Okay, the designer is a user interface tool based on the commands that you view in this HDL compiler. VHDL compiler, design compiler, or test compiler can be invoked. Okay, so first which way you want to start, depending on the commands you give, this will be evoked. Okay, so first code will be tested, then synthesis, then testing. Okay, you can evoke from commands these three compilers. Okay, so first is VHDL compiler. So what it does, the VHDL compiler, generally we pass the compile passes VHDL codes. Okay, then it checks for any syntax errors and any VHDL constructs in the VHDL that are sensible. Okay, means you wrote a code and check for the syntax first, then it will check even for any constraints are there in the VHDL code for synthesis. Means whether we can make this code into some referred blocks, like, right, it generates a report for this with the number of latches, flip-flop, tri-string. These are the primitives. Okay, whatever code you have written, whether it is synthesizable or not, okay, will be checked. So if you have any problem, then it will report errors. So it will tell so many latches, flip-flop, tri-string numbers inbuilt. It will take. Okay, if any warnings are there or anything is missing also, it will tell. Okay, sensitivity list. Okay, so it will optimize your design. See, next is a design compiler. Okay, so the design compiler optimizes the synthesis constraint like speed and area. Okay, so you can specify speed and area constraints. Okay, so it is inside accordingly. Okay, then netlist will be created, and this netlist is used for place and route. Then third one is test compile. The test compile inserts, these are testing methods like scan path, boundary scan, and test access port control, TAPC. Okay, this is for testing your module. Okay, if you insert scan path, that whatever code you have designed, you can test automatically. It can also generate test patterns. Okay, this compiler only is used for testing your code. Okay, using one. Next, last one is the timing. Design timing is timing analyzer. It is used for checking what are the critical paths and perform timing checks. It will check all the timing errors on this. Okay, so same thing is told in these blocks. So you have a design analyzer, then you have a compiler for this. So for the input to the compiler is your VHDL code. Okay, so when this compile output is okay, then you go for the design, compilation and testing. So the input to this is the technology libraries. Okay, gate libraries which will be made inbuilt. Okay, then after you have compiled, a netlist will be created and placed. Suppose you want to test the timings, you can go for the timing analyzer and check. Okay, so this is the flow, and this is your directories, sample directory structure of synopsis. It's same how we are seen for stimulation. This is for synthesis, same files, design, then you have VHDL where the codes files will be generated, then this is used for stimulation purpose, then synthesis. So for synthesis you have this compiler report, compiler margin, format. So when the code is synthesized, the files will be there here. Synthesis files. Any errors I don't know, report errors. Any problem in there, it is area constraints which you have, that all will be stored in this. This is the work. Okay. Then DB, Pargen DB, whatever you want. Then these are the reports that are generated for your files. All reports, area constraint, timing constraint, any critical path constraint, all will be reported in this. Okay, in the report section. So this division is same. Okay. So these are the major files that are for directories structure that is there in the synthesis. Okay, so same thing is explained in this. Okay, using this technique. Okay, this is setup file. You need not explain this so much. You can explain this if you want. Okay, file how it is taking. How can we set this parameters here? Okay. Okay, so these are the report you want to check. Actually, this is file completion report. When you check now, it will show all the status. Okay. So this is the synthesis of your code margin. So when it is synthesized, no, you will get in the form of logs. Inbuilt primitives are there, no, like the tradition. The code is synthesizing. Okay, that's all in this video. Next topic is synthesized technology library. Okay, so you take one example, any full adder, half adder, and explain this synthesis file. Okay. Some example you can take, and when it is synthesizable, this block you can draw. You draw full adder block after synthesis. RTL view will be there, no? Then that you can draw here in the exam. Okay, that's all in this video. Thank you. Please like, do, share, and subscribe to my channel. Thank you for watching.